Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and I am teaching you manufacturing. So in today's class we will be starting our new class discussions, and in this discussion we will be doing some important questions from the manufacturing subject that can come or with respect to your GATE examination. So overall I will be teaching this class in English, and I will be making sure that the questions we do that in such a way that apart from learning the new information or learning or making our concepts strong, we learn some new tips and tricks along the way, so that when the time comes to do that question in GATE examination, we do that quickly and efficiently. So before starting, let's first of all talk about me. So I have secured All India rank of 662 in GATE 2020, that is this year's GATE examination. I have completed my MTech in 2019 from IIT BHU Varanasi, and I have a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are listed in the screen: photo editing, video editing, cricket, football, and I like all sorts of games. So as you can see, the Unacademy app is shown in the screen, and you have to just go and download this app first of all. Believe me, this application will help you a lot in your GATE preparation. So just go to your respective app store, Play Store or Apple App Store, and download this app. Since this app is absolutely free, there is no cost you have to pay to download this app. Therefore, there is no harm in downloading this app. So just download it and just view it, just check it out, that how this app can help you in your GATE preparation. And just for a general rule of thumb, you should just take advantage of everything that can help you in your GATE preparation or in your preparation for getting a job or getting some good college. So if this app is doing the job, if an app is making your preparation better, then just go for it. And as you can see, this app is very properly designed. The upcoming classes, the recorded archive classes, the upcoming test series, the test series that are available are all shown in a systematic and proper manner here. And also all the courses are there in a structured manner. So this app will help you a lot in your GATE preparation. Next, we will talk about the Unacademy subscription. So the Unacademy subscription plan offers a lot of benefits, and they are listed in the screen as you can see. And the benefits are, first of all, daily live classes will be conducted. This means that if you are subscribing to Unacademy, if you are paying a fee, then that payment will be very worth it, because you will have daily live classes, and these classes will just like your traditional classroom classes, because here also the student and teacher interaction will be there. Teachers can interact with student in a manner that is very beneficial, like ask them live questions and all the students can answer them on the spot. And this can create a competitive environment, which is obviously beneficial for GATE preparation, because you want to solve question in current situation, and this creates one. And live test means live test series and all this will be there, and live quizzes means during the classes there will be the questions will be asked which you can answer. And structured courses are there in Unacademy's website when you are subscribing to them. This means that if you are in YouTube, if you are studying in YouTube, then on YouTube you will find that the courses are there in scattered manner. They are not properly placed. You have to go your extra way to just search for them, and this waste a lot of time. So in a structured manner you will get courses, means you will get this just like in your textbook, where you have different topics arranged in your table of contents, and you can just attend them. You can just go through them in a quick manner. And also the courses are made such a way that they are in a progressive manner, and they create a rhythm which is important for your preparation. And unlimited access of content is there, means if you are subscribing now, then you will be getting all the contents before this before your subscription. The previous classes, recorded classes, you will be getting access to all that, and also the upcoming classes will be there for you to attend. So these are some benefits that you can just see here, and you can just check the Unacademy's website. There you can also find these benefits and much more. So just go through them, and if you are finding this important, if you are finding this beneficial, then just subscribe and start your preparation. And Unacademy offers you to study from top educators, and as you can see, these educators are very well qualified, and they will guide you in an efficient and effective way, so that your time spent in the website is worth it. There is no question of wasting your time in the Unacademy's website, because the time taken by these educators, your time will be spent in making sure that you score good proper marks. That is the main aim of Unacademy's this classes. Okay, and all these subjects, multiple subjects, will have multiple educators for you to choose from, study from, and if you finding one educator good, then you can just go with him or her and study in his or her class. And here is the subscription plan payments, and as you can see, there are a lot of options available, but the best plans are the ones which are of more months, that is 12 months, 18 months and 24 months, because these are offering a lot of discount. And over this discount, if you want to just make sure that you get more saving, you save more, then enter the code that is listed on the top left corner of your screen, that is ABHIMI, to get 10% flat discount. Okay, and if you are subscribing to 12, 18 months and 24 months, then you can see that you can save a lot of money and make this affordable, already affordable price, even more affordable, even more you can save in this subscriptions. So I will recommend that you should subscribe for either 12, 18 or 24 months. If you are preparing for GATE 21, then also you should subscribe for 12 months at least, because of the interview preparation and other exam preparation that you can be doing after the GATE exam. And as you can see, these are the plans, these are the subscription information for plus type of subscription. So what is plus subscription? Unacademy Plus offers you classroom experience. So just like classroom, where you have a lot of students studying with you, here also a lot of students will study with you, and you will be discussing with them, they will be discussing, you all will be discussing with the educators. So this will create a classroom experience, and this is one of the better plans that I like the most. And the best plan that I will recommend is 12 months plus for you to subscribe, and don't forget to use this code. And again, there is these are the discounted prices, and as you can see, the 10% code that if you are using, this is the final price that you have to pay. And this price, in this price, you can see that this cost is very much affordable, and you can pay just this much amount of money to get quality education, to get quality preparation, so that when you give your GATE examination, you are sure, you are confident that you have prepared from the best, and you have prepared by giving your level best, and therefore you can just be easy and solve the GATE examination questions, and rest you can just leave it to the performance of you on that day. But before that, you have to prepare, and while your preparation, you have to give your best, and to give your best, prepare from the best, and that is Unacademy. And these are the subscription plans. And there is one more subscription plan, Iconic subscription plan. Here it is just for those who need personal assistance, personal materials, personal coaches. So this plans, again, you can use the code ABHIMI to get 10% off. The code is written in the top of the screen. And again, you can see for personal coaching and personalized test series and all this plan is still very affordable. And if you need this type of subscription, then go with it. So these are the Plus and Iconic subscription benefits. So one of the questions asked by a student here in the chat is the price increased? No, the price is changed a little bit, but they have adjusted, they have decreased the price for certain months, and they have increased them a little bit for certain months. because as you can see, still the prices are very affordable. These are the plus subscription price. The prices you are seeing here are for Iconic. So Iconic are those who need personal coaches, okay, who need a single coaching, one-on-one teaching. For that you need this Iconic. But this is the plus subscription, and as you can see, the prices are not changed that much. It is still very affordable. And the plus subscription here will provide you classroom experience, and again I have just discussed it. Classroom experience in this, you will find that along with other students you are learning, you are studying, you are interacting, discussing with them. So just like in your traditional classroom, you will be studying in the Unacademy classes if you are subscribing to plus. And use this code to get 10% off. Write it anywhere in your copy and make sure to use it, because this will save you a lot if you are subscribing for 12, 18 or 24 months. So this is that for the Unacademy subscription. So the student is asking that it was around 25,000 2 months ago. So yes, the prices have been changed recently. I think just before a month they have been changed. So the new prices are here. The old prices, mainly the effect was for single month the price was decreased, but for 12 months, as you can see, the price have been increased a little bit. But still, if you enter this code ABHIMI, you will get 10% off. Unacademy is offering a lot of content, so it is very affordable in this price also, and it may be possible that prices might get increased in future, because at this price this is just steal. Because this price you are getting this much of content, recorded classes, archive classes, upcoming weekly test series, regularly update that is being done, and also you are getting live quizzes, live test, and structured courses, study material. So you can see that there is a lot of value. So again, 12 months if you want, subscribe. And now we will be starting our class. In this class we will be doing some questions from manufacturing. And before starting, so just wait a minute, let me connect my charger. So sorry for the inconvenience caused. Now we will continue our class. So before starting, this is the code ABHIMI. On all capital letters, get 10% off. So this is the first question that we will be doing, and this is since we are discussing manufacturing subject, we will be doing these questions in such a way that we make sure that we learn something new, and we make new tips and tricks, and we make our concept strong by doing this question. So in the first question, it is asked that basic size of hole and shaft is 25 mm. So what we mean by basic size? Basic size is means that this is the size over which we have to just add tolerance. Okay. So simply, in simple words, basic size is your, as the name suggests, basic or the first size that you have to consider, and over this you have to add or subtract some value to make sure that you have correct tolerance. And for clearance fit, so clearance fit is given in the question. We are provided with this data. Maximum clearance, minimum clearance, and hole tolerance is 1.5 times of shaft tolerance. So what are the limits? Means what are the upper limit and lower limit for shaft and for hole. So if you know the answer to this question, if you know the solution to this question, then just solve it and just write down your answer in the comment section. So if you don't know, then just solve with me or just listen. So what is maximum clearance first? in GATE examination, if this type of questions come, then just write or just remind in your mind that what the things listed, what the data given are. So maximum clearance is clearly given as 0.02. So I am just writing it is 0.02 mm. And what is maximum clearance? It is upper limit of shaft minus lower limit of, oh sorry, I have made a mistake here. It is upper limit of hole minus lower limit of shaft. So this is the maximum clearance value that is given, and minimum clearance, so minimum clearance is given as 0.01 mm, and it is lower limit of hole minus upper limit of shaft. So notice here that, notice in this discussion that when we are writing about clearance, either maximum clearance or minimum clearance, what we are doing here is that we are subtracting hole from shaft. Okay, or sorry, we are subtracting hole and shaft. That is, we are writing the hole first, then we are writing the shaft. And because this is the clearance definition, and maximum clearance is the upper limit of hole minus lower limit of shaft. So what is upper limit of hole? Upper limit of hole is the maximum size of hole, and lower limit of shaft is the minimum size of shaft after we have applied the, or after we have used the tolerance. Okay, so we want to find limits, means we have to find upper limit and lower limit of both shaft and both hole. So in this question, since it is not provided that what is the basis, then if it is hole basis system, or if it is shaft basis system, then just take as hole basis system. What I mean by basis system is, basis system decides that what is the size of hole and shaft. So lower limit hole's lower limit will be equal to basic size if we are provided with hole basis system. So if in question you are getting this term hole basis, then just take the lower limit of hole as the basic size, and by default we are taking this only. And if it is provided with, if the question is given with shaft basis system, then take the upper limit of shaft as the basic size. Okay, so now we know that the question we are considering by default hole basis, so lower limit of hole will be the basic size of hole, that is 25 mm. So this is the lower limit of hole, and after this we can find from here the lower limit of hole we have written here. We can find now from minimum clearance the upper limit of shaft. So upper limit of shaft, what it will become? Upper limit of shaft will be lower limit of hole minus minimum clearance. So lower limit of hole is 25 minus minimum clearance, so it is coming out as 24.99 mm. So this is the upper limit of shaft, and lower limit of hole we have just written here. And now in the question it is given hole tolerance is equal to 1.5 times of shaft tolerance. This means that upper limit minus lower limit hole is equal to 1.5 times upper limit minus lower limit shaft. Because you should know this, that tolerance is the upper limit minus lower limit in every question. In every case, consider tolerance every time as upper limit minus lower limit. So upper limit is the maximum size of that object if we are taking tolerance, and lower limit is the minimum size of that object if we are taking tolerance. So if we are considering tolerance, then there will be, as discussed before, there will be a upper limit, that is upper maximum size, and there will be a minimum size, that is lower limit. So subtracting both of this, we will get the tolerance, and in the question it is given that the hole tolerance is 1.5 times the shaft tolerance. So from here we can just calculate the we can just find the relation between. So let's see what we have here. So upper limit of hole we have to find, and it will be equal to so I think we should do this in other way, because this what will have is, we have, let's see what is the problem in doing this question like this. See, we have the lower limit of hole, we have it, and we have the upper limit of shaft. So we have upper limit of shaft and lower limit of hole, but we don't have this upper limit of hole and lower limit of shaft. Okay, so from this equation and from the first equation we can get two relations, two equations, and these two equations have two variable, and this variable are upper limit of hole and lower limit of shaft, and we can just solve them and find the answer, but it will basically make this whole process a lot more tiresome and a lot more lengthy, so we will be not doing that. So we will be just making figure and we will be calculating it. So this here we will be doing. So consider this as your hole and this as your lower limit, upper limit. This is your tolerance, and let's make your shaft here. This is upper limit, lower limit. So we have calculated the lower limit of hole. It was coming out as 25 mm, and upper limit of shaft we have calculated, it came out to be 24.99 mm. Now we need to find the upper limit of hole and the lower limit of shaft. And in the question it is given that the maximum clearance, that is this value, is given, the maximum clearance, this value is given as 0.02, minimum clearance, this value given as 0.01, and hole tolerance and shaft tolerance difference is given. Means if this is if the shaft tolerance is x, then this is 1.5x, because it is given that shaft tolerance is 1.5 times the hole tolerance. So from the questions what we can see, here is that so we have our maximum clearance is equal to 0.02 mm, and this 0.02 mm from the figure we can just see this as 0.01, that is the minimum clearance, plus 0.01 plus x plus 1.5x from the figure above. So from the figure above we are just getting this, and from here we will calculate x, and x will come out as x is coming out as 4 into 10 to the power minus 3 . So this x is the tolerance of shaft. So since this x is the tolerance of shaft, therefore upper limit of therefore lower limit of shaft will be 24.99 minus x, so it will come out as 24.86 mm, and this 24.99 is the, as we have discussed before, upper limit of shaft. Similarly, we will have a hole tolerance. So now holes tolerance is equal to 1.5x, so it will be 6 into 10 to the power minus, so here it is 986, so let me just write here 9. Okay, 10 to the power minus 3, and therefore upper limit of hole will be simply 5.006 mm. So as you can see, we have calculated, this question is very good because in this question we have calculated a lot of things. But in the first in the first approach, what we were doing is we were not making the figure. Therefore, that approach got a little bit lengthy. And in that approach, we were getting two equations and in that equations, we have to solve that two equations to get the final answer. But here you can see what we have done, what we have followed the approach is we have made the figure, we have assumed the shaft tolerance as x, then from the question we have been provided with the hole tolerance as 1.5 s, and then we simply just saw the figure and solved the question. And we just remembered the basic that the upper limit and the lower limit are the two sizes of a particular object when tolerance is provided. Upper limit is the maximum size and lower limit is the minimum size. So since there are quite of things shown in the screen now, so let's just summarize that what we have studied here. So I will just quickly summarize it in under a minute. So just make in this type of question, just make first a box, represent this box for hole, and there will be upper limit and lower limit, and this is hole, and make this to represent shaft, and again upper limit, lower limit. And what you have here is you have lower limit of hole known from the question by default hole basis system, and you can calculate the upper limit of shaft. How do you can calculate it? By minimum clearance. And after that you are just seeing the questions and taking this shaft tolerance as x, and from the question this is 1.5x, and this value, this whole value, that is maximum clearance value, this is provided in the question. This value, minimum clearance value, this is provided in the question. So what you have done, you have make sure the maximum clearance, this length is equal to this plus this plus this, and after that you have found out x, and after finding out x, that is the shaft tolerance, you have calculated the limits of the shaft, and after that you have calculated the hole tolerance, and you have calculated the limits of the hole. So this is the final answer, that hole is 25 and 25.006. These are in mm. So these are the limits, and for shaft these are in mm also, these are the limits. So I hope this question is properly understood by you. Now we will move forward and solve our next question. So in our next question, it is given that angle of resolution of stepper motor is 1/100th division of one rotation. Gearbox transmission ratio is given. Pitch of lead screw is given. Length of travel is 24.5 mm. Number of pulses required for traveling 24.5 mm is, that is length of travel. For length of travel we have to find number of pulses. So what it is asked in question is number of pulses for 24.5 mm is. So in this type of question we will be making sure that the units are properly understood, because this question can be easily done. Any variation of this question, this type of question can be easily solved if you know the proper units of the given data. Now basic length unit, we have to calculate it first. Why we are calculating it? Because basic length unit is mm per pulse. So this is the basic length unit that we have to find. And how we can find the basic length unit is, we have our resolution of stepper motor, which is 100th of division of rotation. So let's first just simply, and we have transmission ratio and we have lead screw pitch. So this 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 will give you the answer in mm per pulse. So how this is giving you the answer in mm per pulse is, we have our pitch of lead screw as mm per revolution. The transmission ratio, we are multiplying it because of the because the transmission ratio here is the you can see say the velocity difference, so velocity ratio. So therefore, to calculate the this basic length unit, we have to multiply it because it will change our basic length. Okay, so this 1 by 100 is given as, so as you can see, after we have, you know, the units, you know this units, and after you are calculating it, after you have properly just written this, you can see that the thing that is left here is mm per pulse, and that is the basic length unit that we are calculating. So basic length unit here will come out as, so let me just write it, it will come out as 1 by 100, that is 0.01 mm per pulse. So this is the basic length unit, means for a single pulse, how much length we are getting, and this is the shortest unit, so shortest length. Okay, and in this question we are finding basic length unit because we want to find number of pulses, and basic length unit is the shortest unit that is being traveled. So here we have number of pulses now. So for number of pulses, by seeing the units here only, we can just write number of pulses will be length of travel, that is 24.5 mm. This is the length of travel divided by basic length unit. So basic length unit is in mm per pulse, so you will find this will get cancelled, and your answer will come out as 2450 pulses. So this is the answer, this is the number of pulses required for traveling 24.5 mm. What we have done here is, we have calculated the basic length unit, and how basic length unit is calculated, you have to just see the pitch of lead screw, and you have to multiply it with the as you can see, revolution per pulse, which is 1 by 100 given in the question. And if transmission ratio is given, then just multiply it as it is in the basic length unit to get your final answer of the BLU value. And after that, we have just seen the, you can see the units, and just see that we have to cancel the mm, and we have to make that pulse above in numerator. So we have done this, and by just logic, you can also just say that we have 24.5 mm distance to travel, and this much distance is traveled in one pulse. So how much distance will be traveled in and how much pulses will be required to travel 24.5 mm. Therefore, this is the number of pulses. So simply basic length unit is the shortest unit length and here involved here, and we can say that it is the mm distance traveled or distance per pulse that has been concerned here. So the correct answer is 2450. Now the next question here is for turning process, and in the turning process here we have been provided with the turning process question here we have been provided with idle time per piece, cutting time, each tool tip life, changing of a tool tip, and we have been provided with this Taylor equation, which is Vt raised to the power 0.5 is equal to 500, and it is asked that the life of each tool tip in minutes when machined at the optimum cutting velocity for minimum tool machining time per piece. So in the question we we are being asked that for minimum tool machining time per piece or maximum productivity, the optimum time, what will be the optimum time? Okay, yeah, we have to calculate the life of each tooltip, that is the optimum life. We are calculating it after this process. So what we will be doing here is why we have written maximum productivity here. First of all, I will discuss it, because minimum tool machining time simply translates into maximum productivity, because if the time will be minimum, there will be more production done. So maximum productivity is the other way to say that this. And we know that T naught, so we know that T naught is equal to tool changing time 1 minus n by n, and here we can say TS is not the cutting time, it is the time of changing of a tooltip. To change time is TC, sorry, T not TS, TC. TC is the change time, and it is 2.5 minutes, and n is the exponent in this equation, tool life equation. So we will find it as let me just write it, 2.5, 1 minus 0.5 divided by 0.5. So it is simply coming out as 2.5 minutes. That is the optimum time, that is the life of each tooltip in minutes. So we can also calculate here velocity, optimum velocity for this this much of time, that is 2.5 minutes. So optimum velocity will be simply V T naught raised to the power 0.5 is equal to 500, and T naught we have calculated it as 2.5 minutes. In this tool life equation, always we have to always put T naught in minutes. So you have to always put this in minute, and let's just calculate it. So V optimum velocity for this maximum productivity is coming out as 316.22 meter per minute. And as you can see, the unit of velocity that is coming by default here, because here we have taken some constant, and this constant is calculated after taking this units, that is time in minutes and velocity is in meter per minute. So you have to, by after finding this, you have to remember this unit, so that you don't make mistake, or you won't make mistake. So again, how we have calculated this question, there are a lot of times given in the question, and this question mainly I solved it here is because in this question you can see there are a lot of times, lot of different things that are provided in the question, that a lot of data provided, but we have to only use the tool change time data, and the changing time of tool is 2.5 mm, and we know that for maximum productivity, this is the formula. The formula for maximum productivity is T naught is equal to TC. Okay, T naught is equal to TC 1 minus let me write with different color pen. So T naught is equal to TC 1 minus N divided by N. So this is the uh, formula to calculate the maximum productivity time, and after doing that we can calculate optimum velocity also for maximum productivity, which we have written here, which we have done here. So this is the answer to this question. Now I will continue this class in just a second, in just a minute. So I will be back. After the break, and now let's continue our class. So we have solved this class in sorry, not class, we have solved this question, and in this question we have to calculate the tool life, optimum tool life for maximum productivity. And simply the formula was that we discussed Tc 1 minus n by n, and n is the exponent from the Taylor's tool life equation that we have just written here. And we have, there are a lot of times given, so you can get confused that which time you have to use, or you have to use all the times. No, you have to only use the tool changing time, because that's the one that is there in the equation that we have to consider here to get the answer. And after finding the optimum tool life, we can just find the optimum velocity for this data, or for this consideration, and therefore we have also found that also to just know the answer. So simple question, a lot of times given, we have to keep this question, we have to keep our answering a very simple. Even if the question is providing us extra data, we don't have to be panicked. We have to just follow the thing that we have studied. And therefore, as you can see, this question solution is basically 2 or 3 line solution, and not 2 line, only 1 line solution is there, but I have calculated something extras. So you have to just make sure, be confident in what you are preparing and what you are prepared, so that even if something not normal or something different comes, you can just be prepared to do that. Now we will do this question. In this question also there is a little bit of trick, or little bit of newness involved, because what we calculate in our normal classes, what we do in our normal classes, we do questions in such a way that it is basic, it clears the basic concept. But here we have been provided something different, so let's see. In a drilling operation, a drill is used operating at 400 rpm. So it is given that rotational speed of drill is 400 rpm. Feed is given as 0.5 mm per revolution. So this is feed. And torque is given. Now you will think that why torque is given in this machining question, because when we were discussing this, when we were doing learning our normal classes in which we were discussing the topics, there was no torque involved. So why is torque here? Let's see. And here it P is given. So P is basically specific energy is here given. So let's write it P only. So specific energy unit is joule per mm cube, and diameter of drill is asked. So diameter of drill is asked and the unit in which it is asking is mm. So this question since is little bit different. So in this type of questions, to do this quickly, to don't take time in understanding this question a lot, because you have to ultimately solve the question. You don't have to understand word by word of it, because in your GATE your main aim is to score good marks. There is a lot of time you will get for understanding in your interviews and all that. So in the questions, if a new type of questions come, first thing you need to do, see what type of data are given and what is asked, then see the units. So here we can see that specific energy is given as 5 joule per mm cube, and torque is given as 20 Newton meter, and we have been given with N, which is 400 rpm. So we will find here material removal rate, and after material removal rate we will be finding the diameter of drill by calculating the material removal rate and using that value. So material removal rate is area of cut into Fn feed rate. So area of cut will be pi d square by 4 into Fn. So this Fn we know, we have to just find this area of cut, and for this we have to calculate MRR, material removal rate. And material removal rate here we can calculate it by this formula also, that is material removal rate is equal to this specific energy 5 joule per mm cube so let us just write it like this. It will be torque into omega, that is the angular speed, divided by the 5 joule per mm cube. Torque into omega will be joule per second, that is the power, and from here we can get mm cube per second material removal rate. So material removal rate, what it will come out as, just calculate the we have been provided with the torque and we have to just calculate the omega, that is 2 pi n by 60. So here material removal rate we have to calculate in a different way. We have to first calculate torque into omega, that is power, and after calculating that power we are dividing it by specific energy, that is given in the question as 5 joule per mm cube. So just calculate T into omega. So omega is 2 pi into n divided by 60 into 20 divided by 5. So here we can calculate the material removal rate as 167.55. So torque given, omega we can calculate, specific energy given, so we have calculated simply the material removal rate. This material removal rate we will use the other formula of material removal rate, that is the area of cut into this feed rate, so to get the diameter of drill. So this diameter of drill will simply become, feed rate is 0.5 and RPM therefore 400 by 60, because this material removal rate is in mm cube per second. So what we can find here is that we can find our final answer, that is the diameter of drill. The final answer is coming out as let me just check it out. Let me just check T into omega. So it is 2 pi n divided by 60 into 20 divided by 5, and we have to so we are getting answer as these values as 8 mm. So this is the diameter of drill, and as you can see, what we have done here is quite simple, quite easy. We have not calculated something a lot different, so you can just find it by doing this process. So let me check the answer here, because the answer key I have written is I have written it as 61.98 mm, so it is quite different that than we have what we have calculated. So let me check if the data I have written in the question is correct or not. So just give a second. So the answer that I have calculated is absolutely correct, and I think the answer key that I have written was wrong. So the answer key was wrong, but the answer I have calculated here, the process I have followed here, is absolutely correct. You have to just find material removal rate by the given data, that is torque into omega, divided by your specific energy that is given, specific cutting energy, and after that you will just use the basic MRR equation, that is area of cut into Fn, and then after that you will find the your final you can find your final diameter of the drill. So now our next question we have: during orthogonal machining, shear angle is given as 30 degrees. So it is given shear angle 30 degrees for minimum power assumption. For minimum power, what we use here is we use Merchant equation. Therefore, we will have phi equal to 45 degrees plus alpha by 2 minus beta by 2. Okay, so this is the merchant equation. Why we are using it? Because minimum power consumption is the thing that is given, and we are not being provided with the alpha and beta. If question provides alpha and beta, then there is no need to use minimum power consumption merchant equation for that, because already alpha and beta are provided. So already we have this value, and this value is there. We cannot just change it after using the merchant equation. But here, since the values are not given, therefore we have to use this merchant equation to find the alpha and beta for the minimum power consumption. So in the question we have to simply calculate the thrust force to cutting force ratio, and to calculate this ratio I will just simply draw the merchant circle, and in that merchant circle you can see that how easily we can calculate the answer. So let me just erase it. So this is your tool. So what we are doing here is we are calculating merchant circle, because in the question we have to calculate the ratio of thrust force to cutting force. There are multiple ways in which we can do this question, but we are doing this question in this manner because this is the easiest manner. So here so as you can see in this question, what we are doing, let me just see where my calculator is. Wait a second. So let us draw this properly. After that we will be solving this question. First we will draw this merchant circle properly. So to draw merchant circle, first draw the tool and then draw this line. Okay, this vertical line, and after that extend this and make a 90-degree turn here. So this represents along the face length, the force represents the frictional force, and here we have normal force, and just join this to get the resultant. And this angle here is the beta angle, that is frictional angle. Okay, so and what is this angle? This angle is the alpha, that is the rake angle. So this is alpha, and this will also become alpha, that is rake angle. So here we have to find the ratio of Ft, that is the thrust force, and the ratio of Fc, that is cutting force. So here your Fc is there, and here your thrust force is there. This is 90-degree, this is 90-degree. So this angle, what this angle is, see the data is provided, and just quickly tell what this angle is. This angle is beta minus alpha. How this is beta minus alpha? And as you can see, this is beta. Okay, this is alpha, this is 90-degree. So this angle will come out as beta minus alpha, and this is also 90-degree. Okay, so these are the 90-degree angles, and here you can say now this Ft and FC triangle we will consider now. So this is FC, this is FT, this is R. This is beta minus alpha angle. So in this triangle, FT by FC is equal to tan beta minus alpha. So in this angle, if you take beta minus alpha tan, tangent of beta minus alpha, you will get FT minus FC ratio. So to calculate the ratio of thrust force to cutting force, what we need is we have to draw the merchant circle, and after that we will just calculate the tan beta minus alpha and we will get the final answer. Okay, so beta minus alpha we need to calculate now. Now just let me erase it. So merchant equation theory will give as phi is equal to 45 degrees plus alpha by 2, that is plus half of rake angle, minus beta by 2. From here beta minus alpha is coming out as phi is given as 30 degrees, and in the question shear angle is 30 degrees, so it is coming out as beta minus alpha is here we have calculated it 30 degrees. Okay, and tan of beta minus alpha, simply tan 30 will be 0.577. So this is the value, this is the answer of the question. This answer is very simple. You have to just remember this. You have to just remember that tangent of beta minus alpha is equal to FT by FC, then you can calculate it. I have just shown a part of the merchant circle so that you can understand where this tan beta minus alpha is equal to FT by FC is coming from. But the answer is, the solution is quite simple. It can be done in one line in a matter of seconds. Okay, so this is the thing that you have to just see here in this type of questions. Don't use some predefined formulas. Use the merchant circle only and calculate it by using the circle's geometry. Okay, and remember that key tan beta minus alpha is equal to FT by FC. So do remember this formula, and if you remember this formula, then it is even better, because this is a common type of question that is that can be asked in GATE, or that is asked in GATE and ESE. So remember this, tangent of beta minus alpha in merchant circle is FT by FC, where FT is the thrust force and FC is the cutting force. So we can easily calculate the solution. We can easily calculate the answer here by using this and in a line. Now another question we have been provided is the net heat supplied in an arc welding process is 1200 joule per mm. Melting efficiency is 45%. Welding speed is 6 mm per second. And rate of melting is provided as 15 joule per mm cube. Calculate the area of the joint. So, given heat supplied is 1200 joules per mm, the unit is quite different of the two heats given. Melting efficiency 45%, welding speed 6 mm per second, rate of melting. Now rate of melting is simply heat required for melting, so it is 15 joule per mm cube. We have to calculate the area of a joint, that is we have to calculate AB in mm square. So to calculate AB, what we will do here is, first of all we will just multiply the heat supplied with the efficiency. So 1200 into 0.45, we will get the net heat that is actually supplied after multiplying with the melting efficiency, because not supplied which is being used, because this 0.45 that we have multiplied with the heat supplied, and the 0.45 is melting efficiency. Therefore this much heat will be required to melt, and this is here given in joule per mm. And we have our rate of melting as 15 joule per mm cube. So what we will do here is we will simply make the division of area here. So it will come out as joule per mm cube. Again, by units we are seeing that area's unit is mm square, and we have this unit, we have joule per mm, and we have to find the melting heat in 15 joule per mm cube. So joule per mm cube is the unit that we need, but we have joule per mm in the question, it is given as, so we have to find area of joint. So again, area of joint we have to divide it. Logically you can also do this, or you can also do this by seeing the units. So here AB will come out as so AB is coming out as 36 mm cube. So this is the answer, this is the area of joint, and as you can see, the question is quite easy. We are not doing anything different. We have been provided with the heat supplied, and in that heat supplied we are multiplying with the efficiency, melting efficiency, to get the required amount of heat for melting, and that required amount of heat in melting we are getting in joule per mm, and therefore we have to divide it by area so that our unit will become 15 joule per mm cube. Joule per mm cube will be the unit that we will have, and after that we are just equating it, we are just making it equal to the this rate of heat melting given, and area of joint, area of the weld bead can be calculated from there, and it is 36 mm square. So that's it for today's class. If you found this class discussion helpful and beneficial, if you found some new tips and tricks, if you found some something that is improving your performance, then just hit the like button and make sure to subscribe to this channel and hit the bell icon after it to get the notification. After you get the notification, you can just attend live classes, because whenever live classes will be happening you will get notification early, so you can just properly schedule, you can just properly attend that class after managing your schedule. So ABHIMI is the discount code, that is the code you have to enter. You can enter to get 10% off while you are paying for Unacademy subscription. Do subscribe to Unacademy. There the interface there, the discussion is a lot more cleaner because of the tools involved, because of the things that Unacademy's website provide, features that they provide. So use this code while you are paying, and you can share this code with your friends and other students, because multiple accounts can use the same code. And again, thank you for watching. Best of luck for your preparation. Stay safe, take care. So that's it for today's class.